All right, hello everyone. Welcome to today's lesson on working with fractions. All right, so when it comes to math 9 or pretty much all the math after this, you'll be working a lot with fractions. All right, so this is again just a quick little review on everything we can do with fractions as of grade 9. All right, so our first problem is converting between improper and mixed fractions. Right, as a reminder, right, mixed fractions is when we have a big number followed by a fraction. Right? It's essentially saying this is 4 point something, right, as a number. Now, in order to convert mixed fractions into improper fractions, the first thing is to multiply the whole number, right, the whole number by the numerator. Oh, sorry, the denominator. Always get those two mixed up for no reason. Right, so the whole number by the denominator. Right, so the big number multiplied by the number at the bottom. And then we add that product. As a reminder, product is just the answer from multiplication. Multiply the product, or add the product to the numerator. Right, to the numerator. And lastly, we keep the denominator as the same. Right, that's a lot of steps, but it's just 3. Right, so first step, we multiply the big number, the whole number, by the denominator, or the bottom. So we have 4 times the 5, step number 1. Step number 2, where we add the product, so we add whatever this is to the numerator. So we add 3 to that. And then we keep the denominator, which is 5. So all we have here is 4 times the 5, which is 20, plus the 3, 23, over 5. And that's it, we're done. Alright, so just 3 steps. If we have a negative number, or a negative fraction, we just leave the negative sign outside. Right, so once again, whole number times the denominator, which is 7, plus our numerator, we keep the denominator. 10 times the 7 is 70, plus a 2, 72. So it's negative 72 over 7. And that's it. Right, and of course, as you can imagine, if we go from mixed to improper, we multiply. Or go the other way around, we just divide. Right, so to convert backwards, improper back to mixed, we divide the denominator, right, into the numerator. So the bottom number, or the top number divided by the bottom number. Next, we write the remainder, right, in the numerator. We keep the denominator. Right, so if we remember, a fraction is pretty much just a division sign. Right, the whole fraction thing, we write fractions like this, is because this is what a division sign looks like. Well, you essentially have a number on the top divided by a number at the bottom. Right, so this first question is literally just what is 23 divided by 5? Right, that's what fractions are. It's just a division sign. So we just divide. 23 divided by 5. Right, we set our long division. How many times can 23 go into 5? Or how many times can 5 go into 23? 4 times. Because if we do 4 times 5, you got 20. We subtract the rest. And we get 4 remainder 3. And so now, to write it as a mixed number, we have the answer, the 4, as a whole number, and the remainder as a numerator. Again, so the denominator does not change. And that's it. And so in both cases, the denominator stays the same. And as you can see, that's how we go backwards on the first problem. Right? It's the exact same fraction, just switching between the two. Again, as usual, negative sign, we just kind of leave it out. So here we're doing 63 divided by 10. 10 goes into 63 6 times. That's 60. We have a remainder 3. which means that our mixed number, right, our answer is 6. So we have the 6 was a negative because the answer started as negative. We keep the denominator, which is 10. And we'll put the remainder as the numerator on the top. Negative 6 and 3 over 10. Alright. So now that's how I convert between the two. And now, when it comes to fractions, us mathematicians are super lazy, right? We do not want to work with big numbers. So what we can do is reduce them. We are essentially making a bigger fraction into a smaller one, but keeping proportions the same. Right? We cannot just randomly convert numbers back and forth. We have to make sure that whatever we reduce is the same as the original. So in order to do that, we find the greatest common factor. The greatest common factor, or the GCF. Between the numerator and the denominator. And all we have to do is to divide both the numerator and the denominator by the GCF, and then that's it. Right, so now the greatest common factor is essentially the biggest number that can divide into the top and the bottom. So for example, 10 over 15. Right, what's the biggest number that can divide into the two? Right, so we know because the ending is 0 and the 5, we know they're both divisible by 5. Right, we can divide the top by 5 and divide the bottom by 5. 10 divided by 5 is 2, 15 divided by 5 is 3, and that's it. Right, so 10 over 15 is the exact same as 2 over 3. The only difference is that it's smaller. Right, we're working with smaller numbers. Right, and now with negative 32 over 48, once again, we leave this angle sign alone. We know for sure that they are both even. So they're both divisible by 2. Right, so when we divide that, 32 divided by 2 is 16, 48 divided by 2 is 24. Once again, they're both even still, so we know they can be divided by 2. 16 divided by 2 is 8, 24 divided by 2 is 12. A little annoying, but as you can see, they are both divided by 2 again. Or, we also notice they're also divisible by 4. Right, because 8 divided by 4 is 2, 12 divided by 4 is 3. To get negative 2 over 3. And we cannot divide any further. Right, so as you can see, preferably we'll look for the biggest number. Right, because if we just divide by 4 in this case, right, we can just go straight to 2 over 3. Of course, we can divide this by 2. Right, because they're both even, we get negative 4 over 6. But we have to divide by 2 again to get 2 over 3. Oh, my camera's covering it again. Right, so if you can notice right away that there is a greatest common factor, right? We also notice here that, yes, we could just keep dividing by 2 or 4 until we get to the answer. But we can also see that 32 over 48, or 32 and 48, they can both be divided by 16. Right, which just lets us jump straight to 2 over 3. Right, so that's how we want the greatest common factor. Right, if we can find the biggest one, we can just divide both numbers by the greatest common factor and go straight to the answer. But as you can see, even if we don't find the greatest one, that's still okay. Right, we just have to repeat. We just have to keep repeating the steps until you get to the smallest numbers possible. Right, so now, how do you find the greatest common factor? Of course, you can try every single number you know and just hope that it's the case. Right, but here is a guaranteed way to do it. Right, our first step is to divide each of those numbers by a prime number. Right, so prime numbers, those are numbers that can only be divided by itself or 1. Okay, so only divisible. I'll make sure I don't head doesn't cover the writing here, by 1 and itself. Oh, a little bit. All right, by 1 and itself. So for example, numbers like 2, 3, 5, 7, 11. Right, there's an infinite number of them. Right, so as you can see, for 2 here, right, 2 can only be divided by 2 or 1. 3 is only divisible by 1 and 3. But 4, it can be divided by 4 and 1, but also 4 can be divided by 2 to make 2. So prime numbers are only divisible by itself or 1. And yes, if you're curious, 1 is not a prime number. Right, the rule states by 1 and itself, but 1 is only divisible by 1, which is technically itself. Again, complicated stuff, but all we need to know is 1 and 0 are not prime numbers by definition. Again, not really relevant though, but in case you're curious. Right, so now after you divide a number repeatedly by the prime numbers, you pretty much just keep going until you get to a prime number. After that, you write them as a product of prime factors. Alright, so after you find all those prime numbers that you can divide them into, you multiply all together and lay them out. And lastly, once you lay them out, you look at all the prime numbers that the two numbers have in common and then multiply together. So this is what it looks like in practice. Let's say 24, 36. We know for sure 24 can be divided by 4, right? But 4 is not a prime number, right? Because 4 can be divided by 1, 4, and also 2. 2 is a prime number. So let's divide 24 by 2, which is 12. Right, what can we divide 12 by as that's a prime number? We can also do 2 again. To get 6. How about 6? We can divide by 2 again to get a 3. How about 3? Right, we know 3 is a prime number, so we can stop. Do the same thing with 36. Again, we know it's divisible by 2. It's even. Would leave us with 18. We know 18 is even, so we can divide that by 2 again to get 9. And with 9, we know we can divide that by 3, which is a prime number. Leave us with 3, and we're done. So those are all the prime numbers that can multiply into 24 and 36. So we can write this as 24 is equal to the 2, 2, 2, and 3. And so 24 is equal to 2 times 2 times 2 times 3. I'm just writing out all the prime factors here. With 36, 2 times 2 times 3 times 3. Right, writing out all the prime numbers on the side right here. Okay, last step, we just pick up all the ones that they have in common. So, in both cases, they both have a 2. They have another 2 here. And then they both have a 3. Alright, notice how this 2 here, right, 36 doesn't have another 2, and 24 doesn't have another 3. So it only pick the ones that they have in common. So the greatest common factor, whoops. It's just all those remaining numbers multiplied together. So we got a 2 in common, another 2 in common, and a 3 in common. 2 times 2 times 3, which is 12. Which means that if we were to get a fraction, that's, let's say, 24 over 36, right, we can divide both of them by 12 to get 2 over 3, our answer. But to be honest, if this doesn't work for you, you don't have to do it. You can just divide 24 and 36 by 2 by 3 until you get to the most reduced answer. Right, so this method is just a quick way to find the greatest common factor. Again, you can always just guess. And Of course, this works for any number of numbers. You know what I mean. All right, so let's take 9 here. That's divisible by 3. Right, and we're done. 18. We know it's divisible by 2 from earlier to get to 9. And 9 we know it's divisible by 3. Right, again, make sure they're all prime factors here. 45. Right? We know that's divisible by 9. But remember, we have to always make sure that it's a prime number we're dividing with. 9 can be divided by 3, so it's not a prime number. But 5 is. Divided by 5 is 9. Once again, 3 and 3. So we have 9 is 3 times 3. 18. 2 times 3 times 3. Right, again, just writing down all the numbers that we divide them by, or the prime numbers. 45 is 5 times 3 times 3. Alright, let's look for numbers in common. We got a 3 here, and another 3 in all of them. So our greatest common factor is just 3 times 3, which is 9. Oh, sorry. A common mistake that I see people make is, I'm gonna write in red here, right? Even though only 2 to 3s are in common, right? Make sure to not write every single one. Right? This is not the greatest common factor. Right? We're not multiplying all of them together. We're just taking out what's in common, which is 2 of the 3s. But again, you don't have to use this method if you're not comfortable with it. If you ever get a fraction like, say, 45 over 18, right, you can just jump straight to the 9 because we know it's the greatest common factor, which is 5 over 2. Or if you want, right, you can just divide by smaller numbers. 15 and 6, 5 and 2. Right, you can always just go by smaller numbers and still get the same answer, right? So this is just a method that you can use if you like. You actually learn more about this in grade 10, but I'm teaching it to you now if you want to use it. Last topic is converting between decimals and fractions. Alright, so the first step, you place the decimal in place as the denominator. After that, you reduce as normal. So, right here, 0.17. What place value is that? We know that's the hundredths place. It's a second decimal, the hundredths place. So, all we have to do is to put 100 at the bottom, because it's the hundredths place. And then we put the remaining number on top. 17 over 100, and you're done. Right, this cannot be reduced, right, because 17 is a prime number. But also, 100, right, divisible by 2, but not 17. 5, but not 17. We got 10, also cannot be divided into 17. Right, so it works for all numbers. How about this, right? It ends in a thousandths place. So it's something over 1,000. We got 0.025 here, so 25 goes on top. Right, and of course, this can be reduced. Right, we know right away they are both divisible by 5. So divide top amount by 5. But once again, it's still divisible by 5. Right, to get 1 over 40. Final answer. Right, if you want to use the strategy from earlier, right, 25, we know it's just 5 divided by 5. With 1,000, you can divide that by 5 to get 200. Divide that by 5 to get 40. By 5, it's 8. 2, 4, 2, and 2. Right, so this is how you would divide both of those into prime factors. 25 is just 5 times 5. 1,000, 5 times 5 times 5. Oh, sorry, Opossum. I'm going to write over you here. All right, times 2 times 2. We can see there are two 5s starting in common. So the greatest common factor is 5 times 5, which is 25. All right, so off the rip, you can just divide the top by 25 to get to 1. Divide the bottom by 1,000 to get to 40. All right, so yeah, that's why we use the prime factor method. Is it slower? Yeah, sometimes, but it is a guaranteed way to reduce the fractions in one go if you want to. All right, but with that being said, that's it for today's lesson. So thank you for watching, and yeah, good luck on your studies.